Assalamualaikum warahmatullahi wabarakatuh and greetings. Finally, we come to the final topic of EMT, which is electromagnetic field. In this chapter, we will see and discuss the basic principle of propagation wave in unbounded media. Unbounded media is like a free space. And the second part is the Poynting theorem. So it is related to the power. When we talk about electromagnetic field, so electromagnetic field expand from the very low frequency up to very high frequency, such as we have a radio wave, infrared, visible light, where this is the only frequency that we can see. And we have ultraviolet, X-ray, and gamma rays. So each frequency have the different wavelengths, and it has a certain suitable application intended at different frequencies. For example, we have wireless LAN, we have X-rays to X-ray our bodies, we have the gamma rays. In the medical, maybe we have the infrared, and so on. So it depends on the applications. So electromagnetic field is basically produced by the AC current. AC current is a time varying current. So it can produce both E field and H field simultaneously. That means for electromagnetic field, when we have E field, we have H field. In our previous chapters, we know that from Faraday's law and Maxwell equation, the EMT can induce the current and VEMF in a circuit. EMT can exist in free space or other media. For example, we have the guided or unbounded. The three basic properties of EMT wave. First, propagate out in all directions. So EMT can propagate in all directions. Second, propagate in high velocity. So the high velocity means normally is propagate in the speed of light. That's why when we use our mobile to for communications, we can call anybody located very far away, almost the same time because of the speed. And we have to say that the EMT must follow the Maxwell equations for electromagnetic wave. For the wave propagations, so we have a transmission line that we always analyze. The transmission line, for example, we have cable from computer to printer and optical cable. This is what we call as a guided media. EMT can trap and travel inside this media. So this is we call the wired communications, and we have a wireless where we don't have to use a cable. Right, so this is the difference. So as can be seen in this table, in this figure, so as can be shown in this figure, you can see that we can supply, okay, from the power station, we can supply the wave from the input, and it will travel through the media into the output. So we have both. It will travel inside. Okay. A space without a boundary we call unbounded media. For example, we have a free space. Okay. EMT wave travel in 3D directions, and in a long distance, the wave act like a plane wave. So from for example, we have a very small source. Okay, this is source, and when the wave travel far away, so what happened? The wave is just like a plane wave, something like this. Okay, okay, this happen like this. So When it's travel far, it's just like a plane wave. This is what you call a plane wave. Okay. Alright, so let's see one example of wave propagations. For example, in Johor Bahru, we have a RTM stations. So what happens if this station want to transmit the activity, or for example, a song, or any activities from the radio stations? So they will transmit the wave from the station to the nearest uh, towers. Okay, basically the nearest tower is at Gunung Pulai. This is quite a big tower, so the tower will transmit, okay, the information for a longer distance, okay, around it. Okay, but when the wave travel for the longer distance, it will attenuate, right? So when the power of the signal reach below the threshold, so it will not working. So we should whether retransmit again or whatever. Okay,